Suppose I take a tennis ball and I throw up a tennis ball in 26/100. There is air drag on that tennis ball. In the absence of any air drag, I would get a nice parabola which would be completely symmetric. I throw it up with a certain initial speed, v, call it v0, I don't care, and the horizontal component would never change. This would be v0x, would always be the same. But now, with air drag, you're going to see that there's going to be a force, an air drag force in the y direction. If the object goes up in this direction, then there will be a resistive force component in the y direction. And since it has a speed in this direction, there will also be a resistive force in the x direction. So this speed is going to be eaten up in the same way that this component was going to be eaten up. This component is going to suffer. It will not stay constant throughout. And as a result of that, you're going to get a trajectory that looks more like this. It's asymmetric. Clearly you don't reach the highest point that you would have reached without air drag, for the reason that this resistive force in the y direction will not allow it to go as high, that's obvious. You don't go as far as you would without air drag, for obvious reasons that this resistive force is going to kill this speed, but you also will get asymmetry in the curvature, and I want you to see that. I call this point O, this point P, and let's call this point S. So what I will do is I will throw up a tennis ball, and then I will throw up a styrofoam ball. And the styrofoam ball has very closely the same radius as the tennis ball. That means the resistive force is the same on both, because the resistive force is only dictated by r squared and by v, r squared, v squared, remember? However, this has a way larger mass than this one. And even though the resistive forces will be closely the same if I throw them up with the same initial speed, it has a way larger effect on a smaller mass than on a larger mass. F equals ma, right? So on a very large mass, the resistive force will have a much lower effect than on the smaller mass, even though the resistive forces are about the same. So try to see that the tennis ball is very close to an ideal parabola. You will not even see any effect of asymmetry. It will not be the case for the styrofoam, though. So look at the tennis ball first. I should really do it here. Did it look more or less symmetric? Okay, now I'll try this one. Did it look asymmetric? Could you see it? Are you just saying yes, or you really saw it? Let me do it once more. I can throw it back. So now it should curve like this and then sort of come down like that. You ready? You see the asymmetry? Okay, now comes my last question. I'm going to ask you the following, and there's a unique answer to that. I want you to think about it, and I want you to be able to give that answer with total 100% confidence. When this object goes from O to P, that takes a certain amount of time. When it goes from P to S back to the ground, that takes also a certain amount of time. Is this time the same as this time? Or is this time longer than this time? Or is this time shorter? Think about it. See you Friday.